All right, let's take a look at an example here. Senior privileges. You want to gauge student opinion on whether seniors should be allowed to come to school later if they have first block study hall. Suppose the upper school has 100 freshmen, 100 sophomores, 100 juniors, and 100 seniors, just to simplify things. Explain how to select a simple random sample of 100 students. So to get a simple random sample, you can't do any grouping, you can't do anything like that. You just got to put names into a hat and draw them out. So I'll do names into a hat. 1. Number every student from 1 to 400. Assign a number to every student. 2. I'm going to use names into a hat. Oh, crap. I'm sorry. I lost my train of thought here. I was going to do the random integer. I'm going to do names into a hat. Write each name, student name, on a equally sized slip of paper. Put all 400 names into a hat. Thoroughly mix the hat. Not mix the hat. Mix the names, mix the slips in the hat. Draw out 100 names without replacement. We survey those 100 kids. That's how you would get a simple random sample. Don't forget to say that you're going to mix the hat. Don't forget to say that you're drawing without replacement. Don't assume those things. You should put good detail into it. Explain without detail how to get a stratified sample. So to get a stratified sample, I would group kids into grade level. Then take a simple random sample of, got 100 kids, I got 4 grade levels, so I'm going to take 25 kids per grade level. Okay. How might this method be better than a simple random sample? Well, freshmen and seniors may have different opinions, right? Opinions with respect to senior privileges. In a simple random sample, I could get, just by chance alone, 50 ninth graders and 5 seniors. And if I do that, I'm going to get a really bad estimate for the proportion of people that think, that value senior privileges. So maybe the opinion on senior privileges would be really low. Or if I get 50 seniors and only 10 ninth graders, I might get a really high estimate. Okay? Now, normally that doesn't happen. Normally you're going to get nice, balanced estimates, but every once in a while you're going to get a really bad sample. Okay? In a stratified sample, again, I went over this already, but again, you're not going to get these extreme samples. You're not going to get 50 seniors and only 10 ninth graders. So, because each grade probably has similar opinions, or within the grade they have similar opinions, and between the grades they have very different opinions, you should get a sample proportion that is less variable with a stratified sample than you get with a simple random sample. So what does it do? It hopefully reduces the variability or the error in my sample proportion. So I'm thinking my sample proportion may be closer to the true proportion than if I take a simple random sample. Okay, again, that's the advantage of a stratified technique. So suppose a student uses this technique to get a sample. The student, so this is the technique. This is worded strangely. I'm sorry. This student uses a random number generator to select a number between 9 and 12, and then surveys everyone in the grade level of the number that comes up. What sampling technique is this? Is this a good sampling technique? Why or why not? Does it have design? Does the design have bias? Explain. So I'm breaking them into 9th, 10th, 11th, and 12th. I'm breaking them into groups. But instead of picking from each group, aka stratified, I randomly pick one group. So I randomly generate a number. Let's say the 9th graders come up, and I survey everybody in the 9th grade. So this is a cluster technique. This is cluster sampling. And I hope you can see why this is a bad technique. This is a horrible technique. If you get all 9th graders, you're going to get, like if the true proportion of people that think senior privilege is important is going to be here, if you get all the 9th graders, you're going to get a sample that's way low. And if you get the seniors, then you're going to get a p-hat that's really an overestimate. Okay? But here's where you got to be careful. So first of all, is this a good technique? No, of course not. Why is it not? We only get opinions from one class. This isn't representative of all kids and all grades, right? So it's not a good technique, of course. Does the design have bias? And this is where you got to be a little bit careful. A lot of kids would be very careless and just say, yeah, that's a because it's not a good technique, it has bias. Well, no, it actually doesn't have bias. If you get the freshmen, you're going to get a low value. If you get the seniors, you're going to get a really high value. If you get the 10th graders, you're going to get a moderately low value. And if you get the juniors, you're going to get a moderately high value. Is this balanced about the true proportion? Yes. The under and over approximations are kind of balancing each other out. And on average, it is centered about the true value. So it's not biased. But, bias, just because it's not biased doesn't mean it's a good technique. It's bad because my estimates might be really, really far away from the true value. That's kind of the opposite of what's happening here. If you get a stratified technique, you're maybe closer. Your p-hats are closer to the true value. In a simple random sample, they might be a little bit farther off. In this technique, in the cluster sample, you're going to get p-hats that are really, really far off. So if you use cluster sampling unwisely, it's not biased, but it's very bad, or it could be very bad. Suppose you want to select a random sample of 40 seniors from the 100 kids at the school. How might you select a sensible cluster sample? Well, what I'd want to do is I'd want to break them into clusters, not where kids have, not homogeneous groups, where kids have like opinions inside the clusters, but where the groups are heterogeneous, and in each cluster you have a variety of kids. So if I was looking at just getting seniors now, I kind of change in the context here. I'm just getting opinions of seniors. How might you separate the classes into the seniors into clusters? Well, you could separate it by math class, but the kids in Calc BC might not be similar to the kids that are in Algebra 2 or something. I don't know what seniors take. Maybe pre-calc or something. Advanced pre-calc. Regular pre-calc. TMA. The types of kids in each of these classes might not be they're very similar. These ABC kids are, they kind of know their math pretty good, but they're not representative of everybody. So you'd want to break it down into classes or groups where people are more mixed. I would maybe say advisory. I would maybe cluster by advisory. I don't know exactly how advisories are put together, but I know it would be better than grouping by your math class or your science class. So I'd cluster by advisory. I would randomly select 4 advisories and survey everyone in those advisories. I think that would be a pretty effective cluster technique. I don't think I would fall into this pitfall of this here. Now, you never get the advantage of a stratified whenever you cluster. But you should be, if you cluster sensibly, you should maybe be able to do as well as you normally do in a simple random sample. Okay? All right, a couple more examples and we're done here. Life is a roller coaster. An amusement park has opened a new roller coaster. It is so popular that people are waiting in line for up to 3 hours for a 2-minute ride. The park is interested in seeing how people at the park feel about the long wait time. They survey every 10th person in the line for a roller coaster in the line for the roller coaster, starting from a randomly selected individual. What kind of sampling technique is this? So they started a random spot. So maybe they'll start with the 7th person, or I said that before. Maybe they'll do a rand int 1 to 10, and they get a 3. So they take the 3rd, the 13th, the 23rd, etc., all the way down the line. That is a systematic random sample. Is it a good sampling technique? Yes, it's a fine sampling technique. There's nothing wrong with it. What is the population of interest? Now, if they ask you this question, they really need to tell you the population of interest in the problem. You just got to kind of search for it. They are interested in seeing how people at the park feel about the long wait line. So their population of interest is people at the park. Now, if we wanted to really break this down, we talk about people at the park today or tomorrow or in the past or in the future, but let's just keep it simple. It's the people at the park on the day of the survey. What is the sampling frame? The sampling frame are the people that could be selected from the sample. So this is all the people at the park, but my sampling frame, this is my pop of interest, but my sampling frame are the people that could be in the sample. The sampling frame is the people in line at the time of the survey. So the only people that are getting surveyed are the people in line. Not the third, like all the people, 1st through 10, all the people in line at any given time. So anytime there's a difference between your sampling frame, a significant difference especially, and your population, this is where you got problems, okay? Is this sample likely to be representative? Well, what do you think? Do you think the people that are waiting in line have the same opinions about how they feel about waiting in line as all the people at the park? And I hope you say no. Or no. Yeah, no. Yeah, we're gonna have bias, right? Because we got undercoverage, so we're gonna have bias. Now, on the test, when this is just asked, no, that's done. But they didn't ask, does it have bias? Which way is the bias and all that? On the test, I might. So what I would probably say is, if the people are standing in line, then they must be okay. They must be willing to stand in line and wait, right? I mean, they're in line waiting for the ride, so they must be willing to wait in the line. There's a good chance that the people that are not in line look at the line and say, I don't want to wait in line. This is ridiculous. I paid to get in here. I'm not going to wait in line. So it's very likely that the people that are not in line have a different opinion about waiting in line than the people that are in line, okay? So that would cause bias and would cause our estimate to be off in a certain direction, yada, yada, yada. Okay? 15 minutes. I think I'm just going to try to finish this. This last one doesn't take too long. Identify the sampling technique, nice and easy. To get an estimate for the average weight of NFL players, a group of statistics students divide the NFL players by position. So they break them into groups by position, and then randomly select 5 people from each position. So I'm breaking them into groups, and then I take 5 people from every single group. That is stratified. Okay. Stratified random sample. Hoping to learn what issues resonate with voters in a coming election, the campaign director for a mayoral candidate randomly selects 3 blocks from the city. The staff members go to those blocks and interview all the residents they can find on each block. So the city probably has maybe hundreds of blocks or something, right? They randomly take 3 of them and attempt to survey everybody in those 3 blocks. This is a cluster sample. I would actually say it's an attempted cluster sample, okay? The fact that we can't find everybody on that block is a problem. Or I should say, is it a problem? Well, if the people that you find on the block have different opinions than the people that you don't find on the block, if you go during the daytime and you get all the people that are not employed and you don't get the opinions of all the people that are employed, and your question was a job about employment or about the economy or about stuff like that, then yeah, you got a big problem, okay? But they're attempting a cluster. They're just not really achieving it. They're going to have issues with undercoverage. Packing company, packaging snack food, maintains quality control by randomly selecting 10 cases from each day's production. Then they randomly select 3 bags to open, and they inspect the contents. So we got maybe hundreds or thousands of cases. They're going to randomly select 10 of those cases. They're going to take that case, and then they're going to open the case, and then they're going to take a simple random sample of 3 bags. They're going to inspect the contents of those 3 bags. So this would be a multi-stage sampling technique. It's cluster sampling at stage 1, so multi-stage. It's cluster sampling on stage 1. But if it was cluster, then you'd open up all the bags. They don't open up all the bags. They just take a sample of 3 bags. So it's cluster on stage 1 and then a simple random sample for stage 2. Okay? All right. Thank you.